Hi guys. So today we are going to be looking at the dilution of the solutions. And this is a very common technique that is used in the laboratories and particularly in the academic laboratories where we have in the stock room a solution that is coming from the vendors, and these are highly concentrated solutions. And when we are doing experiments in the laboratories, especially where a large number of students are present, we do those experiments at a lower concentration. Or maybe in general, in any setting, experiment may demand a concentration that is, very lower. And so in those situations, you have to make the dilute solutions. So how do we do this? So here's the thing. So first of all, you're going to take a solution that is a very high concentration, and you're going to take a small amount of that higher concentration solution, and you are going to put it into a flask, okay, through the funnel, of course, into a flask. That small amount is put into the flask. As you can see, I have a large number of these red colored dots and a less number of dots in the flask. So a little bit we added. Next, we are going to now add enough water. We're going to add enough water so that the water reaches to this level that we want. So it's not going to be the water is 100 ml. No, it's the total amount of water that is just enough that fills up the level that is our desired amount. Okay, so this contains, as you can see, a very little bit of the more concentrated solution particles, right? And so now this is a dilute solution. Next, you can pour it into a solution, a container, and there you have a solution which has a value of M, which is the molarity, much lesser than the stock solution. Okay, but here's another thing. The volume that you took out from the stock solution was lesser, but the volume that you want for the experiment is much more. So if you see, the value of M1 is higher, V1 is lower. So small volume of is taken out. Now, how much? That is depending upon the formula. And the formula is M1V1 is equal to M2V2. Okay, so once you get that, you are going to get a solution which is much lower in molarity. So M2 value is going to be lower and V2 value is going to be higher. The volume is going to be much larger one. So, okay. So now here's another thing. Ideally, we should convert the volume to liters. But if the volume is milliliters on both the sides of the equations, then that's fine. But ideally, you should convert it into liters. Okay, so we have now these two types of formulas. Commonly, we see M1V1 is equal to M2V2, but we also see in the books C1V1 is equal to C2V2. So whatever you want to use, that's fine. Just keep in mind that on one side are going to values whichever relate to a higher concentration, and on the other side are going to be the values that relate to the lower concentration. So that's one thing. Now let's look at one problem here. What is the molarity of a solution when 75 milliliters of 4 molar KCl solution? So these two are going to go hand in hand. 75 milliliters and 4 molar solution. So you see, molarity and the volume are given. Is diluted means you have added water to a solution to a volume of 500 milliliters. So that's the volume of the more dilute solution. So now you're going to write down M1V1, always write down the formulas. M1V1 is equal to M2V2. Okay, so M is the molarity. So molarity given is 4.00 M times volume is 75.0 milliliters is equal to, we need to find the molarity, the M2 of a more dilute solution, and that more dilute solution is 500 milliliters. Okay, so when you do the algebraic conversion, you have now M2 is equal to 4.00 mol M times 75.0 milliliters over 500 milliliters. Okay, so now these are going to cancel out. The milliliters cancel out, and you are just left with the unit of molarity. So 4.00 molar times 75.0 over 500, and you get, when you do the computation, 0.600 molar. Okay, so this is the value of dilute solution. Molarity of dilute solution is 0.600 m. All right, so that is how you do the dilution problems. Okay, so I hope that you find this to be helpful, and thank you for watching. Bye-bye.